okay? Not a big fan of using lights. Here we are again, talking about safety. Most importantly, your safety and the safety of your loved one. An emergency situation can be a scary aspect, especially if you have a disability. For our system, FRIES, First Response Interactive Emergency System, is designed with the specific needs of individuals that have a hearing or a visual disability. Outline of the presentation. Myself, my name is Elkion. As you all know me as Tony. I'm the product team leader, project manager.
I'm on software lead.
Hi everyone, my name is Isham and I'm the hardware lead for this project.
Hello, I'm Kalan, and I'm also the software lead.
I'm Zavara and the electrical lead. So we're going to start by talking about the motivation behind this project. So if you take a look at the picture on the right, it's a picture of the smoke detector. And whenever we see the smoke detector go on, we see people running to exit because it's a place and it's a lot of chaotic situation. If in that scenario we imagine a person with a visual disability or a hearing disability, it becomes 100 times harder for them because if a person has a visual disability, they have to listen to the sounds coming from the alarm to exit the building, and whereas for the person with a visual disability, it just becomes a lot harder. And so when researching, we saw that there was lack of emergency systems in the market that caters to all the needs, not just partially the needs of hearing and visually impaired. What our system does is it increases your ability to live anywhere in the world because you can just buy the system and put it in your apartment or a house, and it not only helps the people with a disability but also their loved ones and the housing market in general. So in our market analysis, we found 3 systems that were on the market that partially address the needs. The first one is the Lightphone HL. It is a fire alarm clock with a vibrator pad. It uses 5 techniques. The first one is audible alerting. It uses low frequency sounds, so 520 hertz frequencies because they travel longer distances, and audible announcing. So whenever there is a fire, it will just tell them to get out. And the third one is the tactile alerting. The vibration pad. The drawback with that is you need to be in very close proximity because if you're farther away, you cannot wake up with the vibrations. They're not that enough to wake a person up. And the fourth one is the visual notification. As you can see, it's bright red on the screen. The drawbacks with this is this can only be used in case of a fire and when the person is asleep. The second one is the pager. It uses vibrating motions to alert an individual. The drawbacks with this is it needs to be on you at all times, whether it be in your pocket or clipped to you. If you forget it, let's say we're taking a shower and there's an emergency, you're not going to know. The third one is the EM176 smoke alarm system. It has the strobe light and the xenon vibrating pad. With this, it only caters to the need of people with hearing disability and not visual. So all of them do address, but it's usually just in case of fire, whereas our system also addresses natural gas leak and carbon monoxide.
The purpose of our project is to provide a safer living environment for the individual with hearing and visual disabilities. And our system ensures the individual will be notified and their emergency contact will be notified in emergency. And it's affordable and can be installed in any house and any apartment. And our system is designed to provide every basic need of the individual with the visual and hearing disabilities in case of fire, natural gas, or carbon monoxide leak to guide them to safety in an unsafe environment. And also this can also be used by the individual who are expecting safer environment for their families and for their elders as well. And also our project will improve the market because now, as Risham said, people with disabilities will be able to move and live where they want, and they can make their house safer as their needs.
So just an overall system description, we're going to be using 3 sensors: smoke, carbon monoxide, and natural gas. Whenever the Arduino senses one of the sensors, it's going to turn on LEDs. We have red LED to signify danger and white LED, along just rush out and you don't have to make a phone call.
As far as software goes, you can see on the top right, we have our, that's connected to our three sensors, there's smoke, carbon monoxide, and gas. We also have the LCD display that will display the amount of gas or smoke that's in the air. And also we have a speaker in our system, and this is all powered by a 9-volt battery. We put the to the bill so you can see the size of our system. So as you can see, it's very small. It's not like big. This is our testing facility. It simulates a one-bedroom apartment. So you have your bathroom, bedroom, and living room. We put the LCD, the LED in the bottom of the doors, because when there is smoke rises, so you will crouch down, so you can see that building facing. We have the red LED in the main door that tell you that there is a fault in the system, as well as vibrating motors under the bed and couch when you are sleeping, so it can show. On the bottom left, we have the power distribution board for our LED and vibrating motors. So just so our system can run smoothly.
We try to implement a program that's simple and effective, but at the same time tries to grab the attention of a blind or deaf person during the emergency situation. So like we mentioned before, our 3 emergency situations are smoke, natural gas leak, and carbon monoxide. So the detection of one of these 3 emergencies is the input for our system, and once you have an input, then the system response. And we have 5 simultaneous system responses, which are the LEDs flashing the red and white ones. Then you have the emergency situation displayed on the LCD, so if it's a smoke or if it's a natural gas leak. And then we have our speaker sing the emergency message. And then we have vibrating motors underneath, like better couches. And then finally, we have a Wi-Fi module that actually will send out a text message. Upon clicking the resetting button, the system restarts, and then it runs again. And then on the right side, you can see the variables assigned. So we have 3 analog pins for our 3 sensors, and everything else is assigned a digital pin on the Arduino board. These are just the codes for the gas sensors. So if it would exceed a specific value that means danger, then you would have the system running. You would have the LED lights flash, the LCD displaying the message, and you would have our voice message which says, please evacuate respective to each emergency situation. And then we have a EECE411 Wi-Fi module. So we initially wanted to use a Arduino GSM shield, but we ran into a problem because you need a dedicated SIM for that and a monthly expense. So we actually decided to use this Wi-Fi module, which got the job done more efficiently. Testing-wise, we started basically with a unit test where we tested each component in respective to the microcontroller. So this way we knew if something was damaged or not. And then this also prevented delays when we were testing everything together. So in our integration test, this is when we actually tried to run the whole program for the first time. And we ran into like several issues. For example, not enough power supply from the Arduino. So the Arduino supplied 5 volts, and we obviously needed a lot more. We had difficulties in sending text messages with the GSM shield, and a lot of several loose connections were causing the speaker not to function properly. So we solved these issues before performing the acceptance test, and you can see how we rewired everything for better performance. So for the acceptance test, before we ran it, we made sure there wasn't any more problems. So we rewired the whole thing, and the speaker was working this time. We used an 86 battery so that everything was getting the power. And like I said before, we used the ESP8266 Wi-Fi module, and we tested the whole system, and we got the desired outcome.
So as far as project completion and future works, this was a team project. It was very challenging, but as a team, we were able to accomplish it. There was no division in work. So basically, each separate team member did not do one software, one hardware, one electrical. we try to do every task together. So everyone learns the basic, even the fiberglass. We cut it as a team. One person got to turn at it, the next person. When it came to the wiring, even our computer engineers came together and did some of the wiring with us, just so we can learn the aspect. It's a whole learning process. That's what it comes down to for Capstone. Everyone learns something new that they didn't know before. And to make this more official, as you have seen, if we had the time, the mechanical engineering department was a little backed up with a 3D printer. Would I love to print a 3D case, especially since most of the peripherals are modular. So you can see the sensor could be placed somewhere else, and then the whole unit could be, the controller unit could serve more as a main box, as you will see in the fire system. But as I said, we didn't have the ability to have it 3D printed in time. To make this into production ready and for the market, the Arduino wasn't the best choice. We realized that, but we were too far along to go back. A custom microcontroller with a PCB board that will redistribute all the power evenly would have been a more logical choice. Unfortunately, our budget wasn't hard to have that all created in the time frame given. And here we have a little demonstration of the project running. So gas is registered.
Evacuate. 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 Evacuate.
Text message comes in automatically.
Evacuate.
And this is where the motors start. They're vibrating all the basic countries. The LEDs start flashing simultaneously. And you see we put a little toy on top of the couch to see that it's actually vibrating. It's a little difficult to see it if it's vibrating or not. You can feel it, but visual effects, a little difficult to see it. Prototype cost, we try to make it as inexpensive as possible. Looking through Amazon, finding whole kits that would have most of the peripherals that we're gonna need to accomplish the task. That's where we found that Lego had a kit where it had the Arduino Uno that we needed, as well as the wiring and the LEDs, also the PCB board, to set it all together. On the cost also, the whole system runs on two 9-volt batteries. There's two microcontrollers, even though the Arduino is one microcontroller, the ESP82660 is also a microcontroller on its own. It's a standalone unit. It has its own code embedded into the hardware. We found it was more efficient if we wiped the whole system that it had prior, and we reinstalled an Arduino code. So once it receives a power, it automatically sends out the message. There is no separate code running, which created a delay in the long run. So instead of having everything run out simultaneously, everything is running, and all of a sudden, a minute later, you receive a text message. By embedding into the firmware, we're able to get the text message within a couple of seconds. For as far as codes and standards are concerned, this is a life-saving system, and it does have to do with fire safety. There is a preset NFPA, which is a National Fire Prevention Association, that has their code, and for it to be successful, you need to follow their basic procedures, as well as we are using Wi-Fi to make the connections. Instead, as we mentioned and not mentioned before, the GSM module, even though you had a dedicated phone number, it involved a monthly plan that you have to sign up to keep that number active. And when you purchase a system, you don't want to think about the monthly expenses you gotta have. You just want a system that's working. Just like in your home, you buy a smoke detector, you put it in, you don't have to worry about the battery for 10 years. Well, you don't want to have to worry every month, did I make my fire alarm payment this month or not? This system will run on its own, and there is no monthly payments or maintenance associated with it. As far as ethics are concerned, this was a team project. As mentioned, each team member had an equal part in it, in all aspects, whether it was programming, wiring, or even building the testing facility. This project is done with the public in mind, since it is a life-saving safety, and in order for it to be successful, the the public always comes first. It's a fair design system, integrated with the required safety, and everyone can use it. It's not just directed towards individual visual disability or hearing disability. It covers all, as well as the elderly. Last thing you want to do is, in a fire condition, now you have to search for your phone. Call 911. Don't worry, it's simple for you. Just get yourself to safety, and your family members have also been notified. So this creates another freedom of choice, where you don't have to rely on anybody else, you can be on your own. And a peace of mind for your loved ones. Now they don't have to worry about it. If anything is wrong, they'll get the message. A few references that we have used for that. Any questions?
Suggestion.
Yes, sir.
Use different color LEDs for different situations. Because I don't think the person's going to want to read the LCD display when it's on fire.
We thought about that. It will be the RGBs placed down. It require more power.
Well, just ours.
Yeah.
Just cheap.
That's the main focus of the LEDs is just to show you where this exit zone is. So basically, instead of figuring out what is wrong, just follow the LEDs, exit safety, and then the system itself. The loved ones got the message already. Hey, there's smoke detector, there's gas leak. Let's go fix the gas.